Hello, hello. Good morning. Hi, Marissa. Or good afternoon, evening, wherever you are. Oh, bam. No, why is my model not showing? Oh, there it is. It's still really huge like last time. Reset transform. I'll be over here. Alright. Hello, everyone. How you doing? We're doing more Google interview questions today. Oh, are you guys ready for more pain? Hi, Gebre. Hello. Last time we spent 2 hours on one problem. It was this problem. Adjacent increasing subrace detection 1. This time, we're going to be doing its sequel. Adjacent increasing subrace detection 2. I am so ready. Imagine we're here for like 4 hours this time. But hey, we already got some experience from the previous one, so it should be better. 3350. The PAIN is unstoppable of the pain. Yes, it's unstoppable. Okay. Leetcode. What number is this? 3350. 3350. Okay. We can do this. I believe in us. Holy. Okay. Adjacent increasing. Oh wait, I just did this. Wait, did I make a mistake? Was it the number 1 I did not solve? Three, 349. Three, 349. We solved both of these? Dang. What? My mind is what? We solved both of these. What was in your search history? Deborah says, wait, you already did the second one. You implemented relatively quickly this first one. Oh, really? It was. Wait, I didn't know that. Alright then, we're not doing that one. Looks like my memory failed last time. What are we doing today then? Sum of good subsequences. Oh no, it's a hard problem. Do we want to do a hard problem? There's no editorial for this too. You know what, screw it. This might be the only problem we do today. Gabriel says, you solved it quickly actually. The first one? Dang. I think all my memories got overridden by the second one. Okay, 3351. Here we go. Leetcode 3351. I think Marissa was also asking what was in my search history. Oh yeah, I was watching this. There were some other Leetcode VTubers too, which got my attention. Yeah, job stuff. No, you solved the follow-up easier than the first one. Really? Okay, well, my memory's completely apt. I think... The pain must have overridden my memories. Okay. Sum of good subsequences. You are given an integer array nums. A good subsequence is an array that can be derived from another array by deleting some or no elements. Oh, okay. Shizzle. Without changing the order of the remaining elements. Dirty mind plus fast reading. Wait. What did you read it as? Alright. A good subsequence is defined as a sequence of nums where the absolute difference between any two consecutive elements in a subsequence is exactly 1. Return the sum of all possible good subsequences of nums. Oh my goodness. The sum of all possible good subsequences. Since the answer may be very large, return it modulo. Return it modulo? Dang. Note that a subsequence of size 1 is considered good by definition. Okay. Is an array that can be derived from another array by deleting some or no elements. Okay, so we can delete elements, but we can't change the order. So I can straight up just delete 2 over here and then make a subsequence with 1, 1, but it wouldn't fit the good definition. Okay. Jesus. This feels like such a, how do I describe this? Like a interview question. Surely this is no use in real world. Does it? Unless maybe there's some really niche field that uses this. This feels like such a, you will only see this question ever in an interview just because it's so absurd. Oh no. Return the sum of all possible good subsequences of nums. Okay. How do we do this? I mean, how would we do this intuitively? We have 1, and then 2. Okay, well, they say that subsequent size of 1 is considered good by definition, so we can automatically add 3 to all the lanes, I guess. Okay. Could we perhaps do this by recursion? It's the old, we could perhaps do the house robber method, like store the current index in the parameters and then recursively check, either use the next element or don't use the next element. Every time I read one of those questions, my eyes read, but my brain doesn't, just dies. Low-key same. Man, should I even attempt this problem? This feels like such a hassle problem. Are we gonna be here for like 2 hours again? 1, 2, 1. Okay. What do we do for this? I feel like 2, 1, 1, 2, 1. Yeah, recursion sounds about right. Okay. So I'm thinking for every single number in the array, we do a recursive call. And then we do the strategy where we store the index in the parameter, and then we're like, okay, do I use the next one or don't use the next one? And then, every time we do a recursive call, we check the current index, like, is it smaller? Kind of like take, skip way, yeah. You can set yourself a timer after, you can just stop in case it's too hard. You know what, true. Let's do, since this is a hard problem, let's do 20 minutes? Sure, let's do 20 minutes. Bam. Sure, I'm thinking of a recursive call on every single element. We'll have to check somehow if it's bigger or smaller than its previous element. Yeah. Maybe we'll store that in the parameters too. Between any two, the absolute difference between any two consecutive elements in a subsequence is exactly 1. Okay. Yeah, we'll do recursive then. Store the index, possibly the min-max so far, in the parameters as well. Yeah, okay. Sure, okay, and we'll do that for every single element. Sounds like a plan. Oh, okay. And also, we have to sum all of them into... sum all of them with nums. Oh shoot, the modulo too. We have to return the modulo. Oh man. We'll worry about this later. We can do the modulo. Yeah. Wait, what is this modulo actually? Is this long? Int Java int max value 10 to the 9. 10 to the 9 plus 7. 1 billion. Is that the same as this? No, it's not. Oh well, okay. And in the recursion, maybe you can also remember the previous element. That way you can exclude from good subsequence right away. Yeah, I'm thinking about taking the min and max of the current subsequence. Okay, let's do this. So for every single, we're doing this for every single element in nums. We're trying every single starting point. Maybe we can implement some caching later, but yeah, we'll see what we can do. Int I is equal to 0, I is less than nums.length, I plus plus. Man, Google interview questions, hard. Okay. And then we'll do a private method called, what do we do this? This is called the helper method. The recursion, we will take int the current index. We also need, well, we also need a reference to int nums. Should we do the min-max of the current subsequence? Min int max. Sure. What are we going to do next, though? I think that's all we need for now. Okay, and then for every single number in nums, we will get versus the modulo is just so that the total sum doesn't overflow. You can do it at the end. Okay, sure. So for every single number in nums, we run it through a helper. I only understand the train station. I understand nothing, which is basically the problem. I feel like I barely understand the problem too. So int result is equal to 0 for every single number in nums result plus equals the helper method, run through with nums, current index, the current min max, what is it? Just nums I, right, for now. And then nums I, okay. And then at the end, you return result. And we have to remember the modulo too. Okay, now the hard part, figuring out all these stuff. Great. Okay, so first we need to check if the index is out of bounds. So if if index is greater than or equal to nums.length, then you return 0, I guess. We're going to recursively return, return the sum of all possible good subsequences. Yeah, okay. So it's 0 for now. Else, if it's not out of bounds, then we need to check if the current element is, good as part of the sequence. How do we do this? Okay, we need to check if it's 1 away from the min and max. So if math.absolute value, well, let's extract the current number first. Int current number is equal to nums index math.absolute value min minus the current should be less than or equal to 1, and math.absolute value, the max minus the current should also be less than or equal to 1. So if this is true, then that means the current subsequence is good. Yeah, okay. And then we need to update our min-max again, and then we continue recursively. So min is now equal to math.min, the current min, versus my current number, and vice versa for the max. The new max is equal to math.max, the current max versus the current number. Okay, and then we do some recursive calls. Oh, actually, I think you need another loop starting from index right, inside the recursion. Wait, why index right? Oh, shoot. Wait, hold on. Why index right? Would we miss certain cases if we don't do index right? I don't think so. Wait, why do we need an index right? The sum of all good possible. Index right. Oh, okay. I think you need a loop starting from index inside the recursion. Yeah. Okay. For int I is equal to index. I don't think so. We're going to be skipping elements with a recursive call, so the skips are going to add up to start at all the rest of the indexes. Wait, or do we? Yeah, I think it should work this way. Yeah, well, let's just see. Okay. So what are the recursive calls? So we do a... Wait, what do we do? The use next one? Use the next one, or use next. So helper... Okay, we gotta be careful here. Recursive calls. We either do index plus 1, and then the new min, new max. Marissa says, oh, by the way, y'all, in the chat, there is a Discord server in his bio that is free to join. Oh yeah, there is. Marissa actually made it too, with one other mod who is not here right now. Yeah, big thanks to Marissa. She is the MVP in this. Let me see if I can quickly link it in the description too. Customization. Can I straight up put it in the description of this stream? Live. Oh look, I can. Bam. Save. Okay. It should be in the description of this stream now. Join Discord. Yeah, again, big thanks to Marissa for helping make this. Okay, where was I? Oh yes, here. Okay, and the next recursive call is using the helper nums. And then index plus 2, I suppose. Min max. Okay. Whew. Okay, I'm starting to see an issue here. If we do 1, and then 1, 2, and then 1, 2, 1, we basically only do 1, 2, 1, right? Like we only count 1, and then 1, 2, and then 1, 2, 1. All these ones. We count 1, and then 2, and then 1 once. We should be triple counting 1, double counting 2, and then counting 1 just once in the subsequence 1, 2, 1. So I think we should track the current sum in 1, 2, 1. Shouldn't you do result equals plus 1 plus helper? That's what I'm thinking too. I don't think that's the solution to the problem I was talking about though. So we do current plus hold on. Will this actually work? Oh wait, hold on. It might actually work. So we make a result is equal to 0. That's the current number, right? So we do result plus equals current. Oh, it might actually work. Hold on. Yeah, wait. Wait, will it work? Will it work? What if we do result plus equals current plus helper? What's the range of all these integers? Nums is, okay, it has to be greater than 0. Okay. If we're out of bounds, do we just return 0? Why add current to result? You are only counting the number of good subsequences. Oh, because we want to count, like if we have sequence, if the longest subsequence starting on 1 is 1, 2, 1, right? We want to count 1, and then 1, 2, and then 1, 2, 1. We want to triple count 1 in this case, and then double count 2. That was my thinking. I'm really worried about the case where, yeah, so I want to count the current one as its own subsequence, and then I'm going to count the longer subsequence starting at me. Yeah, okay. I'm really worried though. What if the helper, let's do the plus equals here. What if the helper returns like, what if the helper returns like it's not a solution? We start at 1, and we're like, okay, we'll attempt to count the next and the next. You know? And then these return 0 because it's completely invalid, but we're triple counting the current one now, which we should not do. Okay, that's kind of tricky. How do we account for all the multi-countings? I feel like we're really close, by the way. Wait, maybe I shouldn't say that. How do we account for invalid stuff? Because 0 could be one of the elements too. Should we store the sum, the current sum in the parameters? Damn. We shouldn't add this one here, right? We should only add it if it's actually valid. So my thinking is the current numbers should be baked into this somehow. Sure, let's delete this then. And then let's bake the current sum. Man, the parameters are getting kind of complicated. So int current sum. Yeah, just resolve plus equals helper. Int the current sum will store it in here too. Nums I. Return result from recursion. I was thinking about that too, but the elements could be 0 as well. So we can't just say, like, oh, you're saying return result. Okay. Result plus equals the current sum plus current. I think that's a fair thing to do. Yeah, so that accounts for the current sum. The current sum plus equals current, and then result plus equals sum. Yeah, okay. That I believe that accounts for all the previous sums as well. Okay. Yeah, okay. Watch us run this and it doesn't work at all. Okay, I think this works. So let's say we're at 1, right? So the current sum is now 1. And then we branch off into 2, starting off at 2 and then 1. And then let's say for some reason those work too. We would add 3 and then 2. Okay. I think we're on the right track. I don't know what else we can do here. Pass the sum in the helper calls. Oh, you're right. Yeah. Sum. Also, why not result plus current plus sum? Result equals current plus sum. Oh, because I want to update the sum as well, so. Yeah. Okay, let's run this. Compile error plus equals helper 31. The sum is 0. Oh, my time is up. Is this gonna work? Please. No. How close are we? We're really close though. We're a little bit bigger than the output. Should we allot some more time to debug this? Because I feel like we're on the right track here. Let's do 15 minutes. You're adding sum twice. I am. Result equals current plus sum. Result is equal to current plus sum. Wait, where? Are you talking about here? Sum, well, sum plus equals current. That should be right? Is that not? Line 10 to 11 is confusing to me. Okay, maybe we shouldn't. Result plus equals the sum and current. We definitely want to like double count everything from before, right? We established that. Maybe we can just update the sum here. Sum plus the current. And then sum plus the current. Does that make more sense to you? We're updating the sum here. Okay. Yeah, we're close to the number though. Okay. 3 prime says hoi to the hoi hoi. Oh, hey Threeve, how you doing? Do you guys remember Threeve? He's the real software engineer I battled. He's in Albania. Okay, how in the world do we debug this? Okay, let's print the number that we're starting at first. Sequence start is 1 nums I. Okay. And then every time we find a good subsequence, I guess. Absolute difference between any 2 consecutive elements in the subsequence is exactly 1. Okay. Wait a minute. Wait a minute. We only established that the number is a good subsequence here. Why are we adding it here? That makes no sense. We're already adding it into here. We should only do this part if there were questions like these when we had our battle lulls. Oh, that's because I set the rooms to have only easy questions. Wait. Hold on. I think I found the issue. We should only be doing this if we establish that the current number is good for the subsequence. So maybe add it here. Whoop. Result is equal to 0. Okay, so only if... Yeah, this is a hard problem. Yeah, so only if the current number at the current index is good for the subsequence, then result plus equals to the sum plus the current. Yeah, okay. We're on the right track, I feel it. And then you update the min-max. Recursive call use the next or use the result. Run. Okay, we're still wrong. Uh-oh, that's not good. No. Uh-oh. No, why? Why? Result plus equals to the sum plus current. Wait, why do we reset result to 0 every time? Is that necessary? Something smells fishy about setting result to 0 every time. This smells weird. Setting result to 0 every time. Now we're going too small. We're going too big on this one. Uh-oh. Okay, let's print out some stuff for debugging. Stem.out.println. So that means we found sequence ending in... What is this? Current number. Sure, the current number, and then we print out the result. Okay. I feel it. We're close on this one. Sum of current sequence is sum plus current. And then we do some recursive calls, okay. I feel really weird about setting result to 0 every time though. Is that the right call? Because we want to accumulate everything, right? Run this. Oh, hello? Oh, here. Ooh, okay. Sequence starting at 1. Bound sequence ending in 1, yeah, okay. Sum of current sequence 1. Three, okay. 4, Found sequence ending in 1. Okay, oh, the 1, 1, and then 2. Sequence start 2. Wait, I might need some pen and paper for this. Let me see if everything adds up to the desired solution. 16, 14. Sum of current sequence is 1, 3, 4. Found sequence ending in 1, so that's 2. 1, 1 is a solution, right? Wait, 1, 1 is not a solution. Wait, I think I found it. Hold on. The difference between any two consecutive elements in the subsequence is exactly 1. It's exactly 1. Oh, they can't be the same number. They can't be the same number. Oh. Okay, we found an issue. Everything has to be exactly 1. Shoot. Okay. So we can't say less than or equal to 1. It has to be equal to 1. Yeah. Hold on. The difference between any two consecutive elements in the subsequence is exactly 1. So it's useless to store the min and max, right? We should store the between two consecutive. Maybe we store the last one. Yeah, maybe just the last one. Oh shoot. Huh. Okay. Yeah, it's kind of useless to store the min and max, right? And we'll store the previous number then. Yeah, okay. Thanks, Gabriel. So if the previous minus the current is equal to 1, then that means it's good. Okay. So for this one, let's just do minus 1. Sure. Let's stop this. Or maybe we'll just do like -1. It's bogus value. Okay. So if the previous is equals to -1, or yeah, difference between me and previous is equals to 1. So this doesn't work anymore. We'll replace this with current, and then we'll replace this with current. Sum plus current. Okay. Maybe this is the right track now. Sum plus current. Run. Hello. It's all the print statements, isn't it? Please. Oh no. Why is it taking so long? Well, that's not a good sign. Are all these print statements actually slowing it down that much? Thanks, Marissa. Uh-oh. Is it Leetcode's issue? Leetcode, please. Unknown network error. Please try refreshing the page. Okay, fine. Let me copy all this just in case it doesn't save it. Oh. Is Leetcode hiccuping? The refresh is taking a long time too. What if you are always true due to that -1 check? Whoa, what? It's looping infinite? It shouldn't do that because we're always setting Leetcode became Leetcode. We're only setting it to -1 on the initial recursive call when there's no previous element. And then on later recursive calls, we set that to the current element. And all the elements in the nums, it says in the constraints that it has to be greater than 0. So we should be good on that end. No, why? Leetcode. It says gateway timeout, error code 501. Well, that kind of sucks. Is it gonna save my code too? That's local, right? That should be fine. It's okay. I also saved it. Our time is up too. I see it. Huh. Leetcode left the chat. Oh, that's a good one, to be honest. What do we do now? Yeah, what do I do now? Refresh. It doesn't look like... Oh. 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 Is it gonna save my stuff? Only 15 people online now. Oh. Oh, very cool. I think it saved my stuff. Run. Wasn't there another website with Leetcode problems? Cannot find symbol. Min. Yeah, this is completely useless now. I think it was called Leetcode. But it uses Leetcode problems too, I suppose. Let's freaking go! Let's freaking go! Oh! We did it, boys. Wait. We can't celebrate too early. We didn't implement the modulo yet, or do any of the submissions. Hold on, we celebrated too early. We celebrated too early. Okay. Should we figure out what modulo that is? You need to memorize. Yeah. Also the modulo too. Oh. Oh. Man. Let's try without memorization first. If we get a timeout, then we'll do memorization. We also need to figure out what this is. So, what is this, modulo? Okay, and it's definitely gonna time out. Oh man. Okay. Hey, we're on the right track though. We got the right answer, so mod is equal to math.pow 10 to the power of 9 plus 7. Why such a random number? Rip to our boy Chet. No. Is this how you do powers in Java? Java power math.pow. Okay, it's probably right. Yeah, okay. Result plus equals sum plus current. Modulo the mod. Yeah, okay. Modulo the mod. Modulo the mod. Should we do this too? Modulo the mod? Just run all these. Does POW not return integer? Double to int. Oh. It only send me now the message that you're live. Oh, thanks, Gabriel. That's probably better. Oh, wait, no. No. Oh, okay. Okay. I want to try submitting just to see what happens. If it times out, then yeah, we memorize. Wrong answer. No. 49. Expected 68. No. So there's some cases that we're missing apparently. Okay, first of all, why is it 68? Why is it 68? So we have 10. But yeah, how in the world did we get 68? We have 10 and then 9. Hold on. For this problem we have 10 and then 19 using the last 9, 19, and then starting from the other 10 we have 10 and then 19 and then we have 9. Best stream ever. Programmer God, the Programmer God's unofficial assistant. An idiot. No, don't say that. Does that add up to what I want? I think it does. This is 38. 38 plus 20 is 58. Wait. What? Oh. Okay, I'm confused again. Why? Hold on. 10, 19. Yes, 10, 19. And then we have a 1 here. And then we have a 9. It probably adds up to it, right? 10 plus 19 plus 10 plus 19. Yes, I have busted out the calculator. Yeah, it's 68. Okay, why are we not getting 68? Okay, let's debug this. Found sequence ending in found new sequence. So we'll print out the current and the previous. Oh, plus the previous plus the current. This should be more useful information. Okay, and then sequence start. Let's run this. Hoping we'll get some useful information here. Oh, it's at a space between here. That is unreadable. Okay, what do we have here? New sequence. Let's make sure we found every single sequence. So sequence start 10. We found a new subsequence starting at 10. Very good. Sequence start 10. Oh, this is bad. We should have found 9 somewhere. Oh. Oh. Yeah, hold on. We should have found this 9 over here, but we didn't. I see it, I see it. We should be doing the recursive calls regardless if it's a good one, right? Yeah. Yeah. We should be doing the recursive call regardless if the current number makes a good one. Because if it isn't, then we just skip it, right? Yeah. Yeah, okay. Okay. Right, and we only add it if it's a good one. Yes. We return 0 if it's out of bounds. Result is equal to 0. Current is equal to that. Mod is that. Okay. And if it's good, then we add it to the current result. Okay. And then we search next no matter what. Yeah. I think that's it. Imagine if everything just breaks. Okay. What did we return? 78. Ooh. Okay. Okay, it's fine. We debug. This is good though. The first and second cases did not break this time. We start at 10. We found a sequence ending at 10. And then 9. Very good. New sequence start is 10. We found one at 10. And then 9. Very good. We're finding it. 1. We got the 1. And then 9. 9. Wait. Does this not add up to 68? You need to keep the previous item since you're skipping? Oh. You need to keep the previous item since you're skipping. Wait, what does that mean? Oh, wait. I think I see your point. If we use an item, then the previous is equal to the current, isn't it? Else we keep the previous. When it's not a good subsequence. I see what you're saying. Yeah. On the use next. Have you tried telling it to work? It cannot work without your consent. Then the previous is equal to the current. Yeah, okay. Run. It should be another issue though. Okay. Jesus, why is this so big now? What happened here? Okay, we're definitely finding... Wait, what's going on here? Found new sequence 10 to 9, 10 to 9, 10 to 9. Okay, now we're double counting, which is not good. Not sure that will fix it though. I don't think you need previous equal to current. If good, else... Wait, I don't get it. I think we should check the next regardless of whether the current one is a good one or not. Okay, so the issue here is I think multiple recursive calls are getting to the end. That's the issue, I believe. How do we prevent this though? Why is it only failing this third case? My brain. Use next the previous current. Okay, the issue now is that we're double counting the 9 because multiple recursive calls are going to it. How do we prevent that from happening? Remove line 9 and rerun? What's on line 9? Oh, this one? I don't think 19. But we definitely need this line, right? Because if we use a number, then it becomes the previous. Okay, I'll try it though. If we keep the same previous all the time, it definitely will not work. Yeah, it doesn't work. Domain expansion, spinny eyes algorithm. All I see are numbers and problems. Okay, this is really tricky. How do I prevent it from double counting my answers? Because in case 10, it counted 9 twice. I thought you had another run helper inside the if good block. If good block? No, we don't. We just set previous equals to current here. And then else, I mean not else, no matter what, you do the recursive calls with previous. Wait. What if we, is there even a need for this next? Because eventually we're gonna go to everything. Yeah, wait. We don't need the next, right? We're gonna go to everything in here, no matter what. Okay, we're on the right track now. So it only finds, we're at 80, okay. This is good though. It only finds 10 ones and then 9 ones. 10 ones, 9 ones, and then 1, 1. Ooh, we're on the right track, guys. Why is it not getting the right answer though? We're definitely finding the right subsequences now. Is the mod not correct? No, it should be correct. Result plus equals to helper return result. Sum plus current. The previous. Okay, we're on the right track now though. We definitely do not need the +2 one. Wait, based on this, I think we should have gotten the right answer. Sequence start is 10. Found new sequence 10. Okay, plus 19 is 29. Plus 10 is 39. Plus 19 is 58. Plus 1 is 59, 68. Based on this, we should have gotten the right answer, but we aren't returning the correct thing. Okay, so it has to be something with It has to be something with the fact with how we're adding the numbers now. Okay, let's print out some more stuff. Okay, this is good though. We're on the right track. New sequence. Result plus equal to sum plus current. Oh, wait. Wait a minute. We're adding sum wrong. Sum plus equals to the current. We only add the current to the sum if we're actually using it. It got accepted, guys. Let's go. Yeah, woo. Okay. I just spotted another case though. 10-9. Okay, let's just submit. I think I spotted another case where it doesn't work though. Yeah, wrong answer. Use test case. 677. Output 33, expected 46. Okay, we're getting there though. We're getting there. 6, 7, and then 6, 7, right? Okay, if we start at 6, we could end at 6, and then 7. Yeah, we could also potentially skip 7. Okay, I think Geba, you're right. We should have done an else statement here. Else. Wait. There should be a recursive call here, shouldn't there? We could consider... Oh, wait. Oh. So whenever we come across a good one, we could consider skipping it. Like not using it. I love how we used to use a timer just to not listen to it. But we're like really close though. We're like painfully close. Huh. Yeah, okay. Right. We start at 6. We only get to the second 7. Yeah. We're definitely missing that chisel. But then it often overlaps. If the current one is good. Use the next. Huh. Okay, I have to think about this for a second. We definitely need a second recursion. My brain. Okay, so we either have use me or don't use me, right? Don't use me. What happens if we use me? we do this, right? We do this whole shtick. Result plus equal to sum plus current divided by mod. Or, hold on. My brain. It hurts. Ooh. Okay. I'm starting to get confused. Okay. Use next. Is it just me or are there like multiple? There's like 3 cases, isn't there? There's end at me, and then use me, don't use me. End at me is equal to result plus equal to the sum plus the current mod. Okay, that makes sense. We can delete these. So what happens if you use me in the future? We do result plus equals helper nums previous is equal to the current one, and the sum is equal to sum plus current. That makes sense. And then don't use me. Yeah, okay, this is don't use me, which we do no matter what. Result plus equal to nums index plus 1. Good. The previous. Yeah, and then the sum, which is untouched. No, it doesn't work at all. This out of context sounds terribly wrong. Yeah, because the whole use me, don't use me. Okay, well that clearly doesn't work. Let's revert our stuff. Time to look up solution. Yeah, I feel like it's time to look up solution too. Oh, okay, yeah. I'm stumped. Time to look up solution. Microsoft Edge. Editorial, there is no editorial, yay. So we look at other people's solutions. Man, Google problems. Hard as heck. Are people using recursion here? DP, recursive, C++. Oh my god, why is it so long? Dynamic programming. It is time to run to undamage the brain damage. Oh look, it's really short. I like this. Okay, these are our counts, total. Count means the total number of sequence ending with A. Total sum of sequence ending with... Total means the total sum of sequence ending with A, okay. Lee's solution. Is Lee really famous? Lee? Okay. Oh my goodness, what the heck is he doing? Total number of sequences ending with A. Total sum of sequences ending with A. Okay. For every number in A, count A plus 1 is equal to count A plus count A plus 1. Brief. He is known for brief trickery solutions. He is always most upvoted. I see. Yeah, screw this solution. Simple map solution. They say it's simple. The dude who wrote this is the true god. Yeah. Easiest solution and detailed explanation. Why is it so complicated? Holy. Loop through all the numbers in the nums array. Update count I by considering subsequences from I minus 1, I, and I plus 1. Count I plus equals the count I minus 1 plus I plus 1 plus 1. Yeah, is there anyone doing the recursion? Everyone's doing dynamic programming. Cleanest code you'll ever see. So clickbait. DP Java solution. Bottom-up DP. Is nobody doing the... Wow. Wow, this is really simple. DP num plus, oh no. I feel like everyone's doing the same thing. It's like bottom-up dynamic programming. Very easy and intuitive solution. Can't be easier than this. Man, this is like watching YouTube. So much clickbait. Maybe the Leetcode problems are the friends we made along the way. Oh yeah, you can search, huh? How do you search? Oh, here. Nobody really did the, oh my goodness. Why are all the... Yeah, this is a hard problem, huh? Maybe it's time we learn the bottom-up dynamic programming solution. Detailed explanation, okay. Okay. Man, I really wish we can find out the recursion solution for this. Maybe we'll do this some other time, but let's read the dynamic programming one. This variable tracks the number of good subsequences that end with the element. Yes, nums tracks the sum of all good subsequences that end with element I. The sum, oh, got you, okay. Algorithm initialize CNT and sum. For every number in nums, we need to consider how many subsequences can be formed that end with I. We add the possible subsequences formed by adding I to the subsequences that end with I minus 1 or I plus 1. Oh, okay. Or just the subsequence I itself. Oh, okay. That end with I minus 1 and I plus 1. Got you, okay. Update count and sum. For each element I nums, we update count 1 based on the subsequences ending in I minus 1 and I plus 1. Yeah, makes sense. Since the difference between, yeah, okay. Sum I is updated by adding contributions from, yeah, I minus 1 and I plus 1 subsequences, and also considering the sum of the subsequence that end at I. Yeah. Sum get the final result. Okay, I understand his basic reasoning. This is, looks like Python? C++. Why did I say it's Python? Maybe because of semicolons. Okay, the mod is here. We have our map of count and sum. Loop through all the numbers in the array. Update count I by considering subsequences from I minus 1, I and I plus 1. Count I plus equals count. This is a map, isn't it? Oh. Wait. I need to read this really carefully. What's count again? The number of good subsequences that end with element I. Okay. So this map, the key is a number, and then the count is the number of subsequences that end in it. Okay, makes sense. Count I plus equals to the count of all the subsequences that end in I minus 1, or count I plus 1, or just me. Morris says, sorry Chet, but I will leave now in person because my headache. Oh, get well soon. Yeah, get lots of rest. I hope you get better. Thanks for tuning in regardless. I appreciate. And then count I mod. Okay. And then update sum by considering subsequences from sum plus equals I minus 1 plus sum I plus 1 mod. Okay, that makes sense. Add the contribution of the subsequences that end at I. Okay. Long. Some subsequences that end at I. Count I minus 1 plus I plus 1 plus 1. Subsequences from I minus 1, I and I plus 1. What's the difference? This feels kind of extraneous. Add the contribution of the subsequences that end at I. So we add count I minus 1 plus count I plus 1 plus 1. Oh, we're adding just counts here. Okay. Sure. So the difference is we're counting everything that ends here. Okay. And then the sums here. Calculate the final result by summing up all the values in sum. Okay. Wait, I'm still kind of fuzzy on all the add conditions. Let me read this thing again. For every element I, we update count based on subsequences ending at I minus 1 and I plus 1. Similarly, sum is updated by adding contributions from I minus 1, I plus 1 subsequences, and also considering the sum of subsequences ending at I. So these are all everything that ends at I. What is this then? The sum. We're taking the sum. Wait, this is just one thing, isn't it? I don't get it. What's the difference between this? I mean, I can read with my eyes what the difference is, but why are they like technically different? This is accounting for, I mean, my previous subsequences that end in something that can be linked before me, right? That's the sum. From I minus 1, I and I plus 1. Add the contribution of the subsequences that end at I. Which is count I minus 1, count I plus 1 plus 1. I don't get the explanation. What's the difference between this one and this one? Let me duplicate this tab. Let's go to all solutions again. Sum, okay. For each A and A, we can append A to the subsequence. Ending at A minus 1 and A plus 1. Yeah, or start a new sequence with A. Yeah. Count A plus equals count A minus 1 plus count A plus 1 plus 1. Yeah, that makes sense. The sum is, it duplicates the total sum from total A minus 1 and total A plus 1. Yeah, makes sense. And adds count A minus 1, A plus 1 plus 1 of A, which is this thing. We're not even adding sums here, we're adding counts. What's the purpose of this? The sum of the subsequences that end at I sum and count in DP. Should we ChatGPT this? I don't. Okay, let's try something we haven't done before. Let's ChatGPT this. Chat.openai.com. Given this problem, Detailed explanation. And this code has solution. Ask it to implement it with recursion first, maybe. I'm not sure if I want to do it with recursion, to be honest, because DP definitely seems way more simpler. What is the reasoning behind this line? Yeah, okay. Yes, the line in question. The line is updating sum I, which tracks the sum of all good subsequences. Okay. Represents the number of subsequences that end at I minus 1. Okay. So these are the sequences that end. Oh, okay. Yes. These are the counts. Okay. Okay, these are the subsequence that can end here. Multiplying by I, we add the contribution of all subsequences that end at I to the sum of the good subsequences. Each subsequence that ends at I contributes I. Oh. Wait a freaking minute. Oh, shoot. I think I understand it now. So this line is just the sum of the previous subsequences. This is adding my contributions. Like, we're actually, I did not see this times I. We're adding the current element, like, times the number of times that other subsequences use me. Oh, Rick, I understand now. Okay. Oh. Okay, let's do this. I'm gonna try implementing it with the solution right next to me. And then next time we can, when we review it, we'll take it away. Okay. So public. Let's do, we're doing it in Java, okay. Actually, you know what? Let's hide the solution. Okay, I think I can do this. Let's hide the solution. We got this, we got this. So again, we have two maps, hash map, integer, integer. We'll call this count. New hash map. Hash map. Next, we have another hash map called sums, which represents the sums of everything that end in me. New hash map. Okay, and for every single num in nums, okay, we need to increment counts. So count count dot put at the current num, the num is the key right now, is equal to the sum of the counts of all subsequences that end in num minus 1, plus 1, and myself. Yeah. Count.get or default num minus 1 default to 0 plus the same thing but plus 1 and myself. Yes. Because we could just start at myself. Okay. Sum dot put. So again, we're just adding up the previous subsequences now. We're not accounting for the current element. We're going to use the variable in the future too, right? So we can do my count is equal to this thing. And then here we put into num my count. Okay, for sums we put let's do my count, my sum too. My sum is equal to sum.getter default. Yeah, and then sum.getter default n plus 1 plus 1. Not plus 1 though, right? We need to add I somehow. Yeah, just I minus I plus 1. And these are I plus 1 mod. Can we just do plus my count times num? And then sum.put the current num, my sum. Yeah, okay. And then in the end, we return all the sums for every single int key in sum.keySet. And then this is the int result is equal to 0. Result plus equals the key. Wait, no. Sum.get key. Hash m needs to be capitalized. We return result. I forgot the return type. Wrong answer. We are... Oh, shizzle. Num minus 1, default 0, num plus 1. Oh. My sum is equal to num minus 1, num plus 1, plus my count times number. Num minus 1, 0, num plus 1, plus 1. Okay, let's separate this out then. Oh, there's doubles too. Int my count. We need to add it to the old number too. Count dot get or default the current number plus 0. Default 0 plus okay. Sum we need to add it to the old value too. Dot get count I minus 1. Run num 0 plus 1 count dot put my count my sum. Okay, let's take this out. It's different here. But that's literally equal to this. Oh, okay. Take this out. Num, do the old value plus my count. Plus my count times the number. Oh. Oh. Okay. Test case is passed. Okay, let's divide by the mod now. My count is equal to my count divided by mod. My sum is equal to my sum mod. Result is equal to result mod submit. If anything is wrong, it's probably the mod, isn't it? Wrong answer. Oh, yes, it's the mod. Okay, let's move the mod here. My sum divided by mod plus equals okay, plus equals my count times number and then mod again. My sum I think this should be it. My brain kind of right now. Okay, my sum plus equal to okay, you calculate the my sum here, you add it. You mod it. Okay, you mod it here, and then you add the other thing, and then you mod it again. Yeah, what the heck am I doing? Okay, and then you put it in. Yeah. Case 5 is still not working. Is this number like really big? It's like 700 million. Okay, let's take this slow. Let's compare all of our numbers again. How about keeping your sums in long type? Is some in long type? Int maybe? They're doing long here. What's long? C++, what is long? C++, what is long? A Java long, okay, C++ depends on computer architecture. Okay, so just long. Long is just long for Java. Got you, okay. Does this actually matter here? Sum I plus equals. Okay. So it's here. My count times number. Well, we already did the mod here. Sure, let's just copy this entire thing then. Long my count, long my... Wait, they didn't do it here, though. So we copy out this. Okay, num minus 1, num plus 1 plus 1. Mod it times the number and mod it again. Run this, then you don't need to cast everywhere. They also have a plus equals to it, which I did do here. No. We're still getting the same thing. I don't understand why, though. Summing all the values in sum. Your solution is good as is. Just change the types to long, then at the end, since it's int, you return... Okay, sure, let's do long. Okay. You say we don't need to cast anywhere? Your mod is also big integer, make it too long. Ah, true. This should be long as well. Long. Bam. GL. Holy shizzle. Thank you for sticking with me, by the way. Cast it too long. Num. What's num here? Oh. Oh. We need to cast num. Count.put. Sum.put. You know what, let's just set this to integer and then everything else is long. Long result is equal to this, and then we convert to an integer. Wow. It worked, converting to long. Oh. Oh. That has to be a new record. We spent 2 hours on one question again. These freaking Google interview questions. Okay. Leetcode 3551. I'm going to record this question down again. 3551. Okay. Thank you so much again for sticking with me, guys. My phone is out of battery again, too. I think I'll have to end it here. No more system design again. Oh. Yeah. We have done 2 3-star questions in a row now. Yeah, thank you again for sticking with me. I appreciate it. I swear, every single Google interview we've done so far, every question has been insane. Yeah, I've done Microsoft interview questions, Meta questions, TikTok. What else have I done? I forgot. But yeah, Google questions, definitely the hardest out of all the companies. We need to review this in the future. Okay, that's it for this stream then. Thank you again for sticking with me. Oh, Chat versus Circuit Breaker, who is a real CS major, is happening on Saturday, November 23rd, 9 a.m. PST. Basically my usual start time. Yeah, please look forward to that, I guess. And as always, thanks for sticking with me to the end. I appreciate. Bye. Thanks, Gabriel. I appreciate.